Alright, in the first part of this lesson, we're going to just talk about some terminology, and the first one is going to be the imaginary unit I, which is defined as I equals the square root of -1, where I squared equals -1. And you can see that if you square this and square this, you'll get this value. So we're going to use those throughout the lesson. The next thing we're going to introduce you to is the complex numbers and imaginary numbers. They're the complex number is the set of all numbers in the form a plus bi, where this is the a and b are both real numbers, but this is the real part of the complex number and this is the imaginary part. Okay, the next thing we talk about is a conjugate of a complex number. A complex conjugate is of a number a plus bi is a minus bi. So you can see we just changed the sign in the middle. And the complex conjugate of a minus bi is going to be a plus bi. And the multiplication of the complex conjugates gives you a real number. So if we see this below, if you have this multiplied by its conjugate, the imaginary term gets factored out. It simplifies out using these values here. So when what's left is just going to be real numbers. So a real number is going to be, so you can see this is 6 plus 2i minus 8 minus 6i. Alright, the first thing you want to do, anytime that you have subtraction, you might want to go through and rewrite this, and so it'll be 6 plus 2i, and then that's going to be plus -8 plus 6i. Okay, you could, if you could do that in your head, that's fine, but if not, don't forget that that negative is distributed throughout. That's the one mistake most people make. Now, we add the real parts with the real parts, so just 6 plus -8 is just going to be -2, and then 2i plus 6i is 8i. So this is going to be a fairly simple process. This one, it's hard to see these, so I'm going to rewrite them. And we want to square that, so this is squared. So that, let's just write this twice, and what are we going to do with this? Foil it out, yes. So take a minute, foil it out, and then we want to simplify this as far as it can go. Okay, so when we FOIL this out, we get this value, but we know this I squared is equivalent to -1. So anytime we see an I squared, we want to evaluate that and then simplify this out. So we're just going to get, this becomes -1. Actually, let me put that in red. So this becomes -1. So I'm going to have 9 plus, add like terms here, 30i minus 25, and then I want to add like terms here, 9 minus 25, so my answer is going to be 30, actually I was going to say 30i plus minus 16, but let's go ahead and put that value first, the real part first, 16, -16 plus 30i. This is the same thing as 30i minus 16, but it's just more standard to put the real number out front. So we have x squared minus 4x plus 3. So everywhere there is an x, I'm going to put a parenthesis. And then I'm going to plug in 2 plus I. Okay, for this particular part, we need to go off to the side and FOIL that out. So 2 plus I, a binomial times a binomial, you want to FOIL out. So we'll take a few minutes and do that. So we see we get 3 plus 4i. So we're going to come over here and we want to plug in, we want to simplify that to 3 plus 4i. -4 times 2 is -8 minus 4i plus 3. This cancels this, and we get 3 minus 8 plus 3, which is negative 2. The next thing we're going to look at is if we have 2 over 5 minus I. We want to make sure that we don't have that I in the bottom when we want to rewrite this. How can we get rid of the imaginary number in the bottom so that it's only a real number? Multiply by the conjugate. Good. So if this is 5 minus I, what is our conjugate? 5 plus I. But if I multiply this by 5 plus I, what do I have to do to the numerator? Multiply it by 5 plus I as well, so that I'm not changing the value of the problem. We're just changing the form. Okay, and then we just multiply there. And then on the bottom, we had that property that said if you multiply conjugates, you're just going to get the real part, right? We would get the a squared plus the b squared, or the a squared minus the b squared. So what's 5 times 5? 25, so that's our a squared. And what is I times I? I squared. Good, so we bring this minus over, and then I have I squared. Now, what do we know about this? That's negative 1. So the numerator, let's just carry it across. We haven't really done anything with it at this point. So this is 25 minus a negative 1, which is just 26. And what do you think? What about all of those terms? Every term in the problem can be simplified by 2. So reduce everything by 2. And so that would be 10 divided by 2 is 5. I over 13. Now I want you to understand that this exact same answer can be broken apart and be written as 5/13 plus I over 13, or 1 over 13I. Okay, these two are equivalent. If MATLAB gives you a problem with one, then maybe try the other one. Okay, number 5, so let me rewrite this so you can see it. 7 minus 4I plus 3 plus 6I. Just basic addition operation. So let's add the real parts, add the imaginary parts, and we simply get 7 plus 3 is 10. Negative 4I plus 6I is going to be 2I. Okay, number 6, this is 4I divided by 8 minus 9I. Now we want to simplify this, and we don't want an imaginary, we don't want a complex number on the bottom, so what can we do to get that to be just a real number? Good, conjugate, and conjugate of this one is going to be 8 plus 9I. Whatever you do to the denominator, you have to do to the numerator as well. And then let's FOIL this out. So we get 4I times 8, 32I. 4 times 9 is 36, and then we have I squared. Conjugates in the bottom, so safely we can 8 times 8, 64, 9 times 9, 81, and then we factor in the I times I is I squared. Okay? This is negative 1. I squared is negative 1, and I squared right here is negative 1. So for our calculations, we're going to have 32I minus 36, and then on the bottom we're going to have 64. 81 times the negative 1 is negative 81, but what's minus the negative? Plus 81. Good. Which would just give us 32I minus 36 over 145. if I broke these apart into separate, and let me just show you the way you separate them is this. You write this part as a fraction, so it's just 32i over 145 minus, and then this part, which is 36 over 145, which the only thing when you separate them, this one doesn't reduce any, but you have to check to make sure your fractions don't reduce, and this one does. Alright, and let's look at the next one. So negative 8 plus the square root of a negative 32 over 24. Now the first thing we need to do is, this just tells us to evaluate this. We need to figure out what the problem is. Okay? Square root of a negative is an imaginary number, so we actually need to work to rewrite this portion. Now, you have to have some practice with this if you haven't seen this one in a while. I'm going to present one particular method for doing it, and I'm just going to stay, it's a very elementary method, and I'm going to stay consistent with it for those people who aren't familiar. If you have your own method, do whatever works for you. But what I usually do is, you could go out to the side and just divide by prime numbers. Divide by 2 and you get 16. 16 divides by 2, so 8. 8 divides by 2, 4. 4 divides by 2, 2 times. So factor all the way down. And then this, what's the index of a square root? Always a known 2, it's not there. So that's how we do pairs. So I do pairs of 2. Pairs of 2, so basically one pair of 2 comes out front, another 2 comes out front, and then this guy's not paired up, so it's still under the radical. So 2 times 2 is 4 square root of 2, right? So that's just 32, but what do we have? Yes, we have negative square root of 2, so basically what we want to do is negative square root of negative 32 is the same thing as square root of 32 times the square root of negative 1. Now we just took the time to break this down and reduce it. What did we get? 4 square root of 2. And what does this equal? I. So we could just say 4i square root of 2. So this, we would just come back up here and would say negative 8 plus 4i square root of 2 over 24. And the last thing we want to do, let me see if I can get a highlighter here, is this number, and this number, all what? They're divisible. Yes, so let's divide a 2 out of everything. By 4, let's divide a 4 out of everything. Let me get this back to a pen. And so we come down here, and what do you get? Negative 2 plus I square root of 2 over 6. Okay, now if I broke this into individual parts, it would be negative 2 over 6 plus this over 6, but what about the first one? We would have to reduce that fraction. So you can see the difference between when you break them apart, you're usually allowed to, able to simplify a little bit further versus when you leave them together. Since these are rather trivial, this is just the square root of 25 times the square root of negative 1. What's the square root of 25? 5, and what's the square root of negative 1? I. Good, so this is just 5i. And let's bring down this 5 that's out front. We're going to carry this down, and then what's the square root of 9? 3. What's the square root of the negative 1? I. 25i. 3 times 3 is 9i. Add like terms, 34i. And that's a wrap.